And welcome back to another exciting day of mathematics. Whoop, whoop. Warm-up 62's on the screen. Basically, it's just to create a box plot with the data given, 10, 6, 12, 15, and 1. It shouldn't take you longer than 3 minutes, right? Something like that? Anyways, 5 minutes, 5 minutes. I'll give you some time for that. Copy and go. All right, today's going to be a mini session since it's a mini day. Today we're going to continue with one more piece. Tomorrow we should be able to finish already with this chapter, but one more piece that needed to be added to this component. But before we do, let's see. Q1, 2, and 3. Oh, that's not it. Let's see. All right. Q1, Q2, and Q3. Get it started, please. Oh, sorry. Let it go. There it is. Q1, Alejandro. What is it? 3.5. Hands if you got that. That's about right. Q2, Vince. 10. Q3, JC. 13.5. And then Min, Amy. 1. And Max, Amy. 15. So we got there's my box plot. And remind your neighbor, let's see if they remember, what's another name for a box plot? Tell your neighbor what's another name for a box plot. All right. Yeah, it's known as box and whiskers. See the box and then 2 whiskers to the side? Yes? All right. Anyways, copy the agenda for today. Warm-up number 62, measures of position. We're going back to quartiles because we need to add one more component to that. And today being a mini day, I'm going to give you the afternoon off. Is that okay? Yeah? All right. But then I was thinking earlier, I'm like, should I or shouldn't I? Mini day, I think it beckons for something else. And then one of your colleagues walks in and they're like, Mr. Q, they're having a party over here. I'm like, whoa, let's go. I don't want to mention any names. What do you guys think? JC? What do you think? Just say yes or no. No? Oh, okay. Anyways, so last night's home play, I still haven't put that on campus. I'll do that by the end of the day. Make sure you submit that in the afternoon, okay? All right. So get your Cornell note ready. I can summarize data and compute measures of position. We're continuing on. You don't need a fair model. You don't need a Venn diagram today. Like I said, it's going to be a mini lesson. Yeah. You don't need a Venn diagram, no. Oh yeah, yesterday was fun, right? Oh yeah. Was that? All right. So just for the sake of it, tell your neighbor the measures of position, what they are, please. Measures of position. Yeah, so we got those, right? Standard scores or Z-scores, percentiles, quartiles, and deciles. So if you notice, we already covered the top 3. We've been hammering pretty good percentiles and quartiles. Today we're going to finish up with quartiles. And tomorrow we'll finish off with deciles and we'll be done with measures. All right, so we started this week by adding the standard scores. From there we went to percentile. And I said we were going to add one more formula yesterday. There it is. Well, today we're going to still focus on quartiles and deciles. So let's think back to quartiles. Everybody switch to quartiles? Here goes. Quartiles. Tell your neighbor how to find the IQR and what that means. What does IQR mean and how do you find it? IQR. All right, let's see. Maddie, IQR. What was that? Inner quartile range? Yes, that is correct. And how do we find inner quartile range? Yes. Q3 minus Q1, that is correct. So quartile 3 minus quartile 1, that is correct. All right, so we're going to add a little bit more to that one. Write on your papers, outliers, please. And we're not talking about some of your friends. Some, yes, some are outliers. Anyways, outliers are, or should we say, an extremely low or extremely high data value compared to the rest of the data values. Let me repeat that again. An extremely low or an extremely high data value compared to the rest of the data values. And when we are given data, many times outliers mess up the entire data set, or it creates an error just because of that one outlier. Let me give you an example. Let's say this whole class, we're going to pitch in for a gift for Mr. Apodaca. And then we vote and we're like, you know, let's go and let's pick randomly like 6 people, and whatever the, you know, the range of that money that they find, that's what we're going to pitch in. So then I go, okay, first person I pick, Alejandro. Alejandro's out. Okay, I got $5. All right, for him, $5. All right. I pick Jet next. He's out. I got $2, Mr. Q, because somebody stole my $3. I lost them, and you know the stories with Jet. All right. And then from there, I pick Scarlett. Scarlett's out. Mr. Q, I got $4. I'm out. Cool, $4. All right. And then Pedro, how much? Oh, I got $20, Q. I'm like, okay, so $20. There it is. And then all of a sudden, the rest of us, Mr. Q, oh, I only have $2. All right, $2. Boom. And then Mel, how much you got? $3. Boom. All right. So then I said we were going to average it out, and then we were going to all pitch in whatever that average was from that money. Think about all those amounts. If we add them up, which amount's going to mess up the whole average of all those? The $20, is that correct? That's going to bring everybody up to like maybe $6 or $7. You're like, oh, snap, I'm going to have to go wash a car, mow the lawn, or clean my room to get some money, or, you know what I'm saying? In college, some of you are going to find out pretty quick, some of your professors grade using that, using scores, and they go, you know what? The highest score of the class is, I'm going to use that to create a bell curve, and that's going to be your A. So then, let's say today, watch, let's say today I said, clear your desks, and we're going to have a pop party in honor of Mel. She recommended a pop party today. I surprise everyone, and we do a cumulative pop party. What do you think is going to happen with some of the scores? You know what I'm saying? Except for Samuel, of course, he's going to get in 100%, right? And he's going to mess up everybody's scores in regards to his 100%. Does that make sense? So today we're going to be talking about outliers. How do we detect those? Here we go. Write these formulas down, please. Outliers. We got, I just wrote SO, or small outlier. You find that by getting the Q1 and subtracting 1.5 times IQR. And the large outlier, you take the Q3 and you subtract, oh, my bad, this is you add, sorry. Here you add 1.5 times IQR. Those are the two little formulas that we're going to use to detect an outlier. So anything that goes beyond whatever that amount is on the low end or the high end, that becomes an outlier. Sometimes we can detect it right away just by looking at it, you know, kind of like if we go, okay, 2, 4, 6, 5, 6, 7, and all of a sudden somebody 50. Okay, that's an outlier, obviously. But in some instances we can't. So with that said, think about those two and copy this down, please. Example Q. Given the data, sketch a box plot and check for outliers, 25, 15, 10, 15, 1, and 30. Copy that. Look at that data and tell your neighbor what you need to do to get a box plot, and then from there what you need to do to check for outliers. Talk it over with your neighbor, please, and I'll give you some time to do that. I'll give you a head start. All right, help me out, please. Eric, go. What do? Least to greatest, so we got 1, 10, 15, 15, what else? 25 and 30. All right, pass someone. Samuel, Q1, Q2, and Q3. 10, 15, and 25. Hands, have you got that? Looks about right. So this is Q1, Q2, Q3. Continue, Samuel. 1 minimum, 30 max. All right. Next, we need to check for outliers. Pass someone, Samuel. Matthew. Let's check for the smallest one. What do I write? Ten minus 1.5 times what? 15. Tell your neighbor how he got 15, please. Yeah, the IQR. So what'd you get for that, Matthew? Negative 12.5. Okay, so that's way over there. So is 1 an outlier? No. Okay. Pass that one for the high end. All right, so let's see, what did you write? Yeah. And that gave you what, you said? Okay. What'd you get for that one? Training. Should be what? 25. Okay. 25, which is the Q3, right? All right. So 1.5 times 15 plus 25, that gives us what? Jet, go. Hands, if you got that. So do we have any outliers on the low end or the high end? No, so pretty much everything stays pretty close. Okay. All right. From 1 to 5, how comfortable are you with that? All right. So picture this. Example, super Q. Oh, not that. Sorry. It says, Mr. Q gave his stats class a pop party on a minimum day and caught some students by surprise. Mr. Q decides to grade on a curve, just like the college professors. Let's go. Does everybody know now what the curve means? Using the standard deviation and using the scores that are within the average range. He randomly selected the following 6 scores: 100, 85, 75, 80, 85, and 80. Copy those scores, please. Sketch a bell curve and check for outliers, please. I'll give you some time for that. And go. All right, let's see. For the sake of time, here it goes. We got 75, 80, 80, 85, 85, and 100. So far so good, yes? Yes, Mr. Q. All right. Pedro, Q1. Q2. Q2 is 82.5. And Q3? Okay. And then our bell, yes. Oh, my bad. Let it go. There it is. All right. Our bell curve. What was our mean? Pass someone, Pedro. JC? 84.16. Hands if you got something like that. All right. Standard deviation, approximately. Pass someone. 8.61. Hands if you got something like that. All right. Who got something different? Mia, what'd you get? 7.86. So it's around the 8-ish area. So I'll keep it at that. So 8.61. So the first standard deviation should be at what? 92.76. Yes? Going upward. And then downward, we are at 78.55. No? What'd you get on the downward, guys? Saying what? 0.54. Oh, 54. My bad. All right. So in order for everybody to score decent, they need to be in between there. All right. So let's see. Where are we at? 85. 85 is about right here. Another 85. 80 is about over here. 75 riding that line. What else? And 100 over here. Okay. All right. So any outliers? Outliers. What'd you get for the small outlier? Pass someone, Mia. Maddie? Yeah. 70 what? 72.5. Are there any scores below that? No, so there's no outlier in the lower part. How about the larger outlier? Pass someone, Maddie? What is it? 92.5. Is there a score beyond that point? Yes, so it would be the which one? So that is going to mess up everybody's score because that person scored a 100 compared to everybody else that scored within the what? Somewhere in the 80-ish range. So this is what usually happens. The teacher's all like, let's say Mr. Q being a nice teacher says, you know what guys, in order to kind of like keep it all within the A and B area, I'm going to take this one out and just use these in order to find my new standard deviation. Does that make sense? So like that, the standard deviation is going to be a little bit more wider and more people are going to fit within the average range. Does that make sense? Well, students, this is what we call grading on a curve. When you guys get to college and you hear the teacher, I'm going to grade on the curve. Well, there you go. All right? We'll stop right there. Yes? I'm going to try and upload this by the end of the day. All right, so make sure, I'm going to go ahead and upload on Canvas that home play from last night. In a little bit, I still haven't put it in the Canvas, so you'll have till the afternoon to submit that, okay? I'll stop the video right now. What's that? I don't know.